In this problem, we have two blocks A and B. Their masses are given 3 kg and 9 kg respectively. They are connected by weightless links and they're pinned together at point C. And at point C, we have this vertical force. And we need to determine the largest vertical force P that can be applied at pin C without causing any movement. And the coefficient of static friction between the blocks and the contacting surfaces are the same, 0.3. Now, when you look at this language, the largest vertical force that can be applied without causing movement is the same language as the minimum force necessary to cause movement. So these are two different ways to say the same thing. Because again, we're looking at this critical instant when movement is about to occur. So if we analyze the situation, we realize that there are two possible movements. First is the block A slides, as you can tell, to the left, when block B is going to slide to the right. So we're going to investigate these two situations and then determine which situation might occur first. So before we do that, we need to represent the tension force in link AC and link BC as functions of P. So we realize that at point P, we have particle equilibrium. So we have at point C, we have a force P here, and then we have a tension force T BC, and then also tension force T AC at a 30-degree angle with the vertical direction. And even though we cannot solve for all of them, we can solve for TAC and TBC as expressions of P. So resultant force along the x direction equals to negative TAC times sine 30 degree plus TBC equals to 0. And then resultant force along the y direction equals to negative P plus minus TAC times cosine 30 degree equals to 0. So from the second equation, you can solve for TAC to be negative P divided by cosine 30 degree to be negative 1.155 P, and then TBC equals to half of TAC to be negative 0.577 P. So what does this negative sign mean? It simply means that the forces at point C should be compressive. Therefore, initially I draw both forces to be tensile, but now after I have done the calculation, I realize that both of them should be compressive. So this one, AC, is going to be positive now, 1.155 P. Positive because I have already reversed the direction. And this TBC here now is 0.577 P, also positive because now their sense of direction are correctly shown. Now let's start to investigate the situations. First, if block A slides first, so draw its free body diagram. The force is compressive, so we have a force 1.155 P from the link AC. But we still have its own weight, which is MAG, 3 times 9.81 Newton. Normal force currently with unknown location. And also the impending motion is to the left, therefore the frictional force is to the right. So we have along the x direction FSA minus 1.155 P times sine 30 degree equals to 0. Resultant force along the y direction equals to NA minus 3 times 9.81 minus 1.155 P times cosine 30 degree equals to 0. And then, because sliding is going to occur, static friction is indeed the maximum static friction, which equals to mu s NA, which equals to 0.3 times NA. 3 equations, 3 unknowns, the frictional force, P as well as NA. So from here, we can solve for P to be 31.82 Newton. This is not the final answer. This is the smallest force needed for block A to start sliding, or the maximum, the largest force needed for block A to apply on point C without causing block A to move. However you want to interpret this. But then, what if block B slides? Then the free body diagram will be, you will have its own weight, that is 9 times 9.81. We have this force from the tension, 0.577 P. The compression force, and the normal force, MB, not know what it is right now. As you can see, the impending motion is to the right, therefore the frictional force is to the left. So this completes the free body diagram. Similarly, we write our 3 equations. Resultant force along the x direction, this is relatively easier. 0.577 P minus FSB equals to 0. Resultant force along the y direction, we have MB minus 9 times 9.81. The weight of block B is 0. Again, because sliding is about to occur, FSB does equal to mu s MB, which is 0.3 MB. So again, 3 equations, 3 unknowns. From here, we can solve for P to be 45.9 Newton. Again, how do we interpret that? This is again the minimum force needed to cause block B to move, or the largest force that can be applied at pin C without causing a block B to move. So now we compare these two, and we realize that if this is P1, this is P2, then P1 is the smaller one, which means that it's easier to make block A move than to make block B move. Therefore, this is the final answer. The smallest P that can be applied point C to cause any type of motion is 31.82 Newton, and this is when block A is about to slide to the left. So this is the final answer. It can also be interpreted as the largest force P that can be applied without causing motion, because if the force is any bigger than 31.82, if, for example, it's 45.9, but at that point, block A is already moving, because it only takes 31.82 Newton to cause block A to move.